Hello everyone, welcome to From Nowhere to Nothing, Ontological Oxymorons. I'm your host, Joel Bouchard, a doctoral student in psychology, and with me today is a special guest, Keiland Cooper. A couple of days ago, we dissected a clip from the popular TV show The Mandalorian, in which the questions were raised about the droid IG-11, specifically whether he was conscious and autonomous, and what the ethical implications of that might be. Today, we're talking with someone who not only studies learning and memory, but also artificial intelligence. While popular science may be worlds away, the questions it raises are right at our doorstep. All right, Keiland, thanks for coming on the show. Why don't you tell the listeners a little bit about yourself?
So thank you, Joel, for having me here. I'm excited. So my name's Keiland Cooper. I am a neuroscientist at the University of California, Irvine, out on the West Coast. And I'm also the co-founder of Continual AI, which is an artificial intelligence research nonprofit. And just in brief, my research generally is more on the neuroscience side and kind of breaks into artificial intelligence every now and then. But generally overarching all that, I'm really interested in learning and memory. So how our brains can form memories, how they learn over time, how memories interact in the brain and how they link together. And how you can carry that with you over days, weeks, years, lifespans.
All right. Yeah, that's fascinating. You work on a lot of subjects that we talk about obsessively on the show. You want to start by telling us, in its most basic form, what is intelligence?
That's one of those big questions in science that you're going to get a different answer for probably anyone you ever ask. I actually have a list of quotes of people answering that question. Like Stephen Hawking has his famous quote. It's like, intelligence is the ability to adapt to change. But I come from, and I think unfortunately a lot of my opinions on these topics will kind of fit the same, that the big words in brain science will end up usually being a bag of a bunch of subtopics that we just kind of generalize over. And I don't know, I think most people have that sort of opinion. Like, what was it? Like the Einstein quote? It's like, you don't judge a fish's intelligence by its ability to climb a tree, or something like that, right?
Yeah.
So it's going to be species dependent. It's going to be person dependent. It'll be field dependent. But I think intelligence and, like cognition more generally, is this thing that we know humans can do and humans have that most other species or even inanimate machines can't do. I think that's pretty much the safest criteria, and from there you can build up on what specifics you want. Yeah.
Okay, yeah, that's great. I remember I got my master's degree in education, and I remember, from class to class, there was people saying, "Oh yeah, Howard Gardner has a theory of intelligence, saying there's multiple intelligence and all this different stuff." And then the next class, it was, "No, that's debunked. Like, that's not a real thing." So yeah, the jury's definitely a little bit out on how you would define that. And I think that you brought up a really good point. That intelligence is species dependent. I've talked about it a couple times on the show. There's a documentary I like on Netflix that shows what the world looks like through different creatures' eyes. And the scientist who is bringing it up is like, you have to remember, this is just an approximation, because essentially you're using a creature's eyes, but you're interpreting it through a human's brain. And that's not how it works in real life. So obviously this sort of spills over into artificial intelligence, right? We're talking about something that is much different from people or animals or anything else. So it's an interesting spot to start. And you seem uniquely qualified to answer this question. What would make intelligence artificial? When we use that term, what do we mean by that? Are we saying anything that's not human, or how are we using it?
Yeah, no, that's a good question. And jumping back to when you were talking about species, there's like an awesome famous paper, forget who it's by, but it's what's it like to be a bat, right? So, trying to think about what it's like to, in the case of echolocation for a bat, what would it be like to navigate the world through the sense that humans really can't comprehend? Although there were a few recent studies about blind humans who could potentially use echolocation. I don't know if you've ever.
Yeah, I saw that.
I don't know how true they are, but if true, then that's pretty cool that we can do it. But yeah, I think it kind of hits on these things that big words or specific abilities kind of go into our schema of what these large cognitive terms end up being. Jumping back to your last question about if we wanted to recreate these in a machine and do we call them artificial? I personally don't like the term artificial intelligence because I think you kind of shoot yourself in the foot from the get-go. For example, when IBM developed like Watson to play Jeopardy or Deep Blue for chess, people always say like, wow, that computer, we put the benchmark in the ground and we say, if the AI can do X, it's probably smart or it's probably intelligent. And then obviously somebody goes out, builds the machine that can blow humans out of the water in that task. And then all of a sudden the field goes, wow, okay, yeah, that wasn't so hard. Computers could easily do that task. That's not real intelligence. It's not really intelligent to play chess. Or 50 years ago, if you saw that, or I guess later now, 100 years ago, if you saw that, you'd be like, wow, that's amazing. So the benchmark's always moving. And I think if what we're trying to build is something that is truly intelligent, when you call it artificial from the get-go, you're not really allowing yourself to believe that whatever it is you're building is real. Or the, these bag of tricks that we can end up pulling out from each individual AI savant. So a machine that's superhuman at chess, a machine that's superhuman at protein folding, a machine that's superhuman at stock market, whatever it is, these specific tasks that, individually, if you would, if you'd be an expert chess player, you'd call that expert chess player intelligent in chess, but you build that computer, beats them. If you call it artificial, you're not really giving yourself much room to allow that to be, okay, well, that's actually, it's not how we solve it, but it is a way that a computer can solve it. So yeah, going back, I wish we would have used the term synthetic intelligence. I think that's more apt term for what we're building. Kind of going to like substrate independent, that just because it's not a brain, it's not in neurons, it's in silica, that doesn't mean that it can't be real, so to speak. And even intelligence, I think, is probably, going back to your first question, is probably not the right word to use either, because it's also one of those ill-defined words that doesn't really mean anything out of the context that it's used in. Most people be like, oh, wow, he's really smart. He can do math in his head. It's like, is that really the best way to qualify somebody being smart? I mean, that's a skill that I couldn't do. But so I wish, going back to the 60s and the Macy's conference and cybernetic days, that it would have been synthetic cognition, which, even cognition is a harder to define term. But I think that's closer to what people want. Cognition being kind of the mirror of the human process that we have.
I think that's a good term is the process, right? Because cognition sort of implies a process, whereas, like you said, intelligence is just sort of this abstract kind of concept. In artificial, I think that you nailed it there. It's sort of an anthropocentric way of categorizing something that's other than us in that way, right? So, like you were talking about at the beginning of the show, intelligence is something, in its abstract sort of, term. Exactly. It applies, it applies to all kinds of animals and things. But we're using it in regards to computers, as it only measures up to us, right? Mm-hmm. So do you think if we got to the point where AI could do anything that a human could do, it could, it had cognition in the same way that we do, we still wouldn't call it intelligence. It would still be artificial intelligence because it's other than us. I think that's kind of the purpose of it, is putting it into a category.
Yeah. And I remember back, Dan Dennett, I was at one of his talks and he said something really good about I think he's referring more to consciousness, but it's like the magician's secret, right? It's like when you don't know how it works, it's wow, that's amazing, that's impressive. But as soon as you like reveal the trick of what it is that gives rise, the mechanism underlying it, you go, oh yeah, that's easy. I knew how that went. Oh, I would have known that all the time. That's not that impressive.
Yeah, and that's kind of like Deep Blue winning at chess, right? It's that. Oh, okay. Well, at first it seems like they can't do it, and then they do it. And like you said, it's a moving benchmark. This idea of artificial intelligence.
Yeah, and once you figure out how it does it, that all it's doing is just running a search through every possible iteration of chess, and it's just finding the set that path through search that optimizes the chances of it winning. Like, oh yeah, and it's like, people think that that's what master chess players have a greater, or at least a heightened ability to do, that they can quickly run through, simulations of the chessboard in front of them, but just not at the same rate or capacity as chess would. And, humans also have, heuristics, or what folks like intuition, but.
Right. So you study human learning and memory. Do you think there's other aspects of the mind that are applicable to AI, the development of AI?
Yeah, I mean, I think that the entire history of artificial intelligence and neuroscience, I mean, all of these, let me put it this way, all these brain science fields, and I'll even include artificial intelligence as one of the brain sciences, all kind of grew from the same tree and branch of thought. Just, I think, studied from different perspectives. Neuroscience studies human cognition through the realm of the brain, psychology through behavior, cognitive science through trying to understand the processes underlying cognition, and artificial intelligence, like, can we take all of what we learned or even build new methods to solve these same problems that humans do? And so in the case of artificial intelligence and neuroscience, I mean, those two fields have been inextricably linked from the beginning. Even going back to like the grandfather of AI, Turing. Turing wanted to emulate, a human mathematician to solve a problem with a machine. He, in his later years, was, quoted in some of his writing as really thinking about these computers as kind of, agents in their own right. Von Neumann, in terms of like computer science, his later writings were about the brain. Like his last unfinished work was a treatise on neuroscience, and he never finished it, unfortunately. And even I like to use deep neural networks because they're kind of on everyone's mind. If you go back to the 60s and the impetus of connectionist modeling and these types of models, they weren't really in. Deep learning wasn't really in the artificial field back then. Connectionist models were usually psychologists or cognitive scientists, computational neuroscientists, trying to model some of their behavioral results with some sort of applicable model. And it was out of that the field grew. And then as it grew into modern deep learning, business techniques, statisticians, all of these other kind of fields bled into it and kind of made it more of like a universal function generator where you could apply it to a business use case. You could apply it to supply chain or data science or these other fields just because it's powerful at prediction or classification or what have you. But I mean, I think a good example of what is to come is probably from DeepMind. Because they're one of the key examples of, and Dimas Haspis, he was a neuroscience PhD at UCL doing fMRI before he even transferred to artificial intelligence. But DeepMind has this big thread of integrating neuroscience findings into its artificial intelligence. And it's funny enough, it seems every time they seem to do that, they get a Nature paper that goes through all the newsreels and becomes the next big thing. They used a hippocampal mechanism that was kind of derived from Haspis's undergraduate research to beat a tart. So episodic replay and these sorts of well-known neuroscience findings, and so on and so forth. And so yeah, I think there's a lot, and I think more and more artificial intelligence researchers are interested in pulling from neuroscience and cognitive science to find tricks to do things. The brain solved it already, so it makes sense.
So that's interesting, right? So the history of AI is sort of inextricably linked to neuroscience, and a lot of AI systems are sort of built on that template. Do you think that is the most efficacious way of building AI, or do you think that that's just the intuitive way of doing it, since that's how our brains work?
No, I mean, both have worked. So, I mean, if you look at like the 80s, the what is it, good old fashioned AI, where you explicitly program a computer to solve, this was prior to deep learning and machine learning really being big, and so you explicitly program the task. So say you have like a sort task or a search task, which back then would be pretty impressive if you can have an AI to do these things. You would explicitly give the computer instructions to do it with minimal learning involved, which is not really at all how we solve these problems. And I think it's interesting if you take a step back from this and you kind of look at the spectrum of artificial intelligence, and I'll even throw in computational neuroscience in there. You kind of have this spectrum of, if I have a task, so let's say chess, you could probably build an AI to solve it really close to how a human would, pulling in all the biological, physical properties that we know of today to solve that task. You could also probably solve chess with mechanisms that are not even near what humans would do, that only a computer would do, like brute force search through every possibility or something. And on those two ends of the extreme, you have for every AI algorithm that exists, measured by a function of how close is it to how humans or animals would solve whatever given task you're trying to solve. So, I mean, I think it's probably going to be task dependent which one's better. Obviously, in a memory task, I would trust a computer more than I would trust a person. You have eidetic, one-to-one, every bit is encoded into memory. But, there's other tasks that I think how the human brain solved it was optimized for that kind of task. And so I think it's task dependent. You can solve them both ways. But the specifics of the solution will kind of dictate what advantages, what pros or cons you have at your disposal to complete that task, whatever it is you're trying to solve in AI.
Gotcha. Yeah, that makes sense. I was thinking to myself, that if it was based on the human brain, you'd think at some point, if the technology got advanced enough, it would make sense to branch out beyond that. But it sounds like from what you're saying, they already do in some regards, but in some regards, just good old-fashioned human thinking is sort of better at solving a problem than going through a brute force kind of AI.
And it depends. Like there are some papers now that are trying. So there was one big one that trained a neural network. I think it was to solve like an image classification problem, or whatever. And they designed their neural network to do it. And the trick in that paper was they constrained the architecture and the function of the neural network to be as close as it could be to someone in an MRI scanner solving the same task. And their conclusion was that when you constrain a neural network to mimic how, the specifics of the human brain that they had encompassed, you got far better results. Is that going to work for every application? Probably not. But, it's reasonable to assume that in some cases, the brain has figured something out that is useful. Like, you should use sparse representations rather than dense representations because you're going to improve your storage costs and you're going to minimize interference between representations. Okay, that's probably reasonable. We should probably use that. But other things that the brain does might not be optimized for the task. So I think it'll depend.
Gotcha. So what are some other key differences between how a human brain and an AI system work? So you've talked about, so there's sometimes they constrain the AI to act like a human brain. When they're not doing that, what sort of things are they doing? We've talked about with like, Deep Blue, like going through all of the possible calculations for a chess game or something. What are some other ways that AI solve problems that a human brain wouldn't be capable of doing?
I mean, certainly scale and speed. So in most cases, if you want to scale to huge problems and you want really, a quick ability to do it, you need a computer. I mean, computers are infinitely fast. Infinite is a harsh word to use. Computers are far faster than a human brain is. Like it takes the order of milliseconds for information to conduct through synapse, but it takes nanoseconds through transistor. So there's certainly a speed trade-off, and probably in most cases an accuracy trade-off too. Like these are fuzzy, stochastic little computers we have in our heads, where a transistor is pretty on point. I mean, there's some variation, but it's far more accurate in terms of those at that level of computation. I mean, you couldn't have a Google in your brain. Your brain might work, be able to search through vast quantities of whatever much information you have in your head. But I would be willing to argue if you could possibly quantify that, it would probably be less than Google's search index, which is spread over, huge server farms in multiple countries across oceans. And so, yeah, I mean, scale is probably a big one.
Okay. Yeah, I'm thinking about something real quick. While you brought up memory, which makes sense. A computer has an eidetic memory. Essentially, it's not going to forget anything, right? Whereas humans,
program it, but yeah,
right, yeah. But humans can. Do you think where's AI in terms of? I remember a few years ago, Microsoft had an AI. They released it. It got kind of trolled on the internet, and people turned it into a racist, right? So this is that aspect of learning where it's learning something and it's keying in on the wrong things. Does AI have the ability to are we getting to a point where it can kind of sort through those memories and relearn and kind of erase some of those things the way a human can? If you're a human, right, you can sort of like over time you can learn new patterns of behavior that erase old ones. Does AI have that capability with memories that's already established?
Yeah, I mean, depending on the algorithm, but I think in that case, I think it was Tay was what Microsoft called it. Yeah, but I think in that case it was less a memory problem or even a relearning problem as much as it would be a control problem or even like a decision-making problem. Like humans, us, especially humans relative to most animals, a huge disproportionate chunk of our brain is dedicated to doing nothing else but sending inhibitory projections back to the rest of the brain that basically tell that brain region to shut up. That's the main, if you look at the prefrontal cortex, most of its projections are inhibitory axons going to the rest of the brain that just hush the other brain regions down. And you might think, why is that useful? Because humans are impulsive creatures. We all have these thoughts that we want, and the prefrontal cortex there has learned to just no, not now, don't do that. That's not, that won't complete your goals. It might feel good in the moment, but let's not do that. Let's not take this drug now because down the line it might not, you could ruin your life, or so on and so forth. So I think in terms of Tay, Tay was, I don't know the architecture underlying it, but I assume it wasn't that sophisticated in what it really, it's probably just a language, a simple language, probably not simple, but it's mediocrely complex language AI. Impressive in that, that you could just soak up all the information that people were tweeting at it. But if all you have in that neural network stack is just a language model that's learning, how they work. They're learning the statistics of, word probabilities. So like if I say, when you're typing on your phone and you have autocorrect, most of those are either an AI or a hidden Markov model that's just learning the probabilities between words and saying if I'm saying the cat and there's a high probability the next word will be hat, just because of the statistics of language. Most of those models, up until some more recent ones, don't really have like goal directedness, so they don't have this kind of like I want to use speech to do this, and they certainly don't have I want to say this, but this is bad because X, therefore I will not say this. As humans do, right? Like we learn pretty at a young age, you don't do these things because you'll have a bad outcome. Tay didn't learn that. But I guarantee you, now almost every big AI company has huge divisions and allocating a large amount of capital towards avoiding that problem, to avoid. Another example would be like Google Images. When they unveiled their Google image search, it was awesome. It was breathtaking that you could just search 1,000 photos in your camera roll for cat, and it would just automatically pull up the ones for cat. Awesome. Until some people went through and typed in the word gorilla, and their black friends came up with that, and that's awful. You do not want that to be associated with your algorithm. But that's just, for whatever reason, the AI pulled those features and that's what it learned. And so, you have to go back through and explicitly tell the AI not to do those things, or think of cleverer strategies to avoid those. Usually having biased data is a big one. But yeah, it just takes some doing.
So, how do like AI programmers, how do you achieve that? You're not learning it the same way that a human would, right? If I'm distinguishing between different things, do you have to do more work on the end of the AI scientists? I mean,
it's getting a bit out of my area in terms of I'm sure there's probably two ways that people are approaching it from a research standpoint of how could we implicitly teach these algorithms, these networks, to behave in a more equitable, reasonable, not hostile or offensive way. Is there a way that we can implicitly bake that into how they're training to avoid these kind of maladaptive outcomes? On the research sphere, I'm sure that's the big arching question that a lot of ethics AI researchers are looking into. But probably if I'm a corporation and I'm releasing like Google image search and I'm releasing an actual AI application, a tool, I'm going to have teams that are going to validate it and search and test it and look for those things. And they probably bake in explicitly rules and methods to avoid those things. Just because, in that case, it's code. It's a software product. So you're going to do whatever you can to avoid those explicitly. I don't know how Google is actually handling it, but I would guess that would be what they would do.
Gotcha. Okay. Let's ask some formative questions. Can you tell us a little bit about the origins of AI?
Yeah, I mean, I would think that like the origins of AI probably date back to the origins of the computer themselves, or the origins of automata. And even so, Charles Babbage is usually the first person to think of like the differential calculator to build a machine that can do this once human feat of mental computation. Prior to that, again, calculators are ubiquitous now. I have 4 on my phone and 2 on my laptop and 1 old TI-86, right? But back then, a mathematician would be some reverent, high intelligence person, and to come up and say, I have a machine that can solve differential equations, that would be, encapsulating this high intellectual ability. And even prior to that, there's awesome work within the history of computation, like back in early France, of like these automata. So these machines that can, and it's actually fun if you're ever just bored on an afternoon to just type in like automata France or these things. They have these awesome videos of these very ornately designed machines. There's one where it looks like a human. It's like a robot, and it can write. It can be programmed to write. I forget what it's writing, but it can do these things.
This is really interesting. I don't mean to cut you off. I'll let you keep going here in a minute. But this is something we've talked about in the past. We're primarily a philosophy show, and trying to determine where the cutoffs are with some of these things, like with intelligence. There was a recent study in psychology looking at IQ scores, right? And there's this pervasive sort of feeling among people that people are getting dumber, and it has something to do with technology, right? But what they found is that, well, no, just because you could remember 1,000 phone numbers before, now you don't know your own, doesn't mean that you're any stupider. It just means that you're passing off those tasks to a technology. So they found that IQ scores over time have not changed. People are just just as intelligent in that abstract way now as they were back then. But what they're using their intelligence for is different now than it was then. And a lot of those memory tasks or the computational tasks that have been taken over by cell phones aren't things that are incorporated into the human sort of schemas in a lot of ways. And like you were saying with the when you take that back and you look at it that way throughout history, where do you start drawing the line on when our artificial intelligence, if you're thinking of it as a task that's being taken over from humans so that they can focus their energy somewhere else, where does it begin? It's kind of a fascinating question.
And it's like, when does a pile of sand become a heap, right? It's like all of these fields are interconnected. They all jump back to philosophy at some point, branching in different ways. But yeah, and I love actually the question of like, oh, we're gonna have all these things, we're gonna become so stupid, like the characters in WALL-E who just sit and let the computers do everything for them. And my favorite response is, just read Plato, because Socrates complained and moaned about the same thing, except in their big technology of the time was writing and paper. And he didn't like it because of the same reason you said. Oh, if we write everything down, then we're not going to have the capacity to remember anything anymore. He was absolutely right. Back then, people trained themselves to be mnemonists, to remember, like the Odyssey, for example. People would remember that entire poem. And it was actually, some people hypothesize that poems were used because it aided memory. It was a mimic device because things rhymed. So you could remember longer pieces of information. But I don't think anyone in their right mind would go back and say, yeah, he's right. I wish we didn't have paper. I wish we didn't write things down or develop language. That would have been such a waste of no. The fact that I can even tell that story is because, ironically, Plato wrote it down. Right?
Yeah, exactly. That's the way. Anytime there's a new technology, that's kind of the old guard's reaction to it,
Very
right?
old.
Oh, technology. TV is going to rot your brain. Radio is going to rot your brain. Oh, the internet and now cell phones and everything else. I think where it gets interesting with some technology stuff, right, is it seems pretty obvious. Okay, well, writing is a good thing, right? What do you think would happen to humanity if like a solar flare hit and knocked out all of our electronics, though? Like, then we have to go back to like the primitive tools. Do you think there'd be any kind of gap, or you think we'd be able to pretty much figure it out?
I'm sure we could figure it out. And actually, there's a lot of really good YouTube channels of people trying to do that, of building these primitive things. And there's a lot of anthropologists out there who know the ancient methods of building, Greek arches or these things, or chiseling stones. They know that pretty well. So they would be the first people that we would go to. I think we'd be fine. And also we have a great deal of information, offloaded from the digital. So there's a lot. To go farther than that, there's actually a company that's trying to encrystallize the world's information into, it's a form of data storage and crystals that has a height. But anyway, they're trying to ship them to the moon and Mars. So we have like it's called ARC, I think. And they're trying to have like a repository. I think they have all of Wikipedia on there now and put out in a satellite or something. So we have that kind of like backup of the world's knowledge.
That's cool.
We're smart. We would certainly figure it out.
Yeah,
faster than we did before.
You see, there's a lot of neuroplasticity even within an individual human. So, as a species, or as a societally, I'm sure that if there was some sort of cataclysmic event, we'd be able to get back on our feet. So why don't you keep going? So we've talked. That was kind of a fun tangent on these sort of speculative origins of AI. Why don't you give us like the official account? Where do they say that it starts and how to kind of progress?
Yeah, I mean, again, it really will depend. Like I said, like deep learning, for instance, certainly has its roots in like computational psychology and mathematical psychology, and trying to develop models to mimic psychological experiments. Artificial intelligence itself, it's a big field, and so like early robotics, there's the famous robot Shaky, which was one of the first to like navigate through a room, and laid the groundwork for Roomba and driverless cars and all of these things. Turing is certainly regarded as the godfather of computation, and probably even the godfather of artificial intelligence, given how close those were. I mean, he thought about building to program a computer in the same paper as what it would mean if that computer was so intelligent that we couldn't tell it wasn't a human. So they're inextricably linked. I personally think, and maybe some people will debate it, but I think really the whole field of computer science is in a vein for artificial intelligence. Artificial intelligence is probably the grand goal of why we have computer science and why it's so pervasive. We want to build really smart technologies, as evidenced in Turing. But I think along the way, people are like, well, hey, we can use these computers to do a heck of a lot more than just what humans do. I mean, we can run the stock market and fly a plane and you name it. We can do it. We can tweet. And so, yeah, I think we built something that was useful, and we just appropriated it into every application that we could find it to be useful. But artificial intelligence, I think, has remained in different flavors and different approaches, from a roboticist to someone who's a good old-fashioned AI programmer giving explicit rule-based logic to solve a problem, to the modern deep learning revolution in nowadays. And within that, there are key benchmarks and signposts. Certainly, Kasparov was a big win for AI. Certainly, YouTube's deep learning to find cats from videos was, what kind of sparked this modern deep learning revolution we're in now. All of DeepMind's stuff that are really showing the boundaries that deep neural networks can go. And who knows what the future will be. There's people looking at quantum computing and artificial intelligence, and what will quantum computers allow us to do that traditional computing wouldn't do further. Who knows? But yeah, it's a long story.
So what are sort of some of the chapters in AI's history? Like, how's it progressed? So I'm certain that the AI that we have today and how it accomplishes tasks, AI in history probably didn't accomplish tasks those same ways, right? So what were like some of the original programmings and how things have gone now?
Yeah, I mean, like I was saying, so in computer science, early computer science was kind of regarded as artificial intelligence, things that we wouldn't really think of that impressive now. So there's a very famous programming language called Lisp. Early in the day, and it was, regarded as being, wow, that's impressive that you can get a computer to sort through these things, or can search through text, or these kind of, search in some regards was an artificial intelligence, key benchmark, like tree search. But we really don't think of like brute force search in a computer today as being that kind of that artificial intelligence flavor. Now it's just, every computer science 101 major learns breadth first search and depth first search and all of these different search algorithms. That back in the day, that would be artificial intelligence to do. So yeah, I mean, the further you go back, the more I think AI looks like computer science. Our perception of it is just we're so used to it now that we don't really think of it that way. Same with robotics. Early robotics was certainly artificial intelligence, but now it's just, it's just a robot. It can just drive around. It's a Roomba. Is it really that smart, or is it just a robot?
Yeah, it's kind of like you said at the beginning of the show, like the benchmark's always moving, right? So, now I can play chess against the computer on my phone, and I don't think of that as being artificial intelligence, right? But in some regard, there's somebody somewhere along the way, somebody said, oh, well, we have to have an expert level and a medium level, and the computer's going to have to act a certain way when it plays and do these different.
Now you can play chess against an algorithm that learned chess by itself, that knew nothing about the rules, learned nothing about even the task it was doing. It just knew, I need to win. I'm going to move around until I win. Ooh, that worked. I'm going to do that again. Oh, I did that again. I won. And just, AlphaGo Zero is what I'm talking about. And it can play itself, and it can blow every other artificial intelligence technique out of the water. The ones that use, like Deep Blue did. It had a whole host of heuristics, like you should prioritize your queen over a pawn, so I'm going to value this more in my search, or I want to maximize my knight to do right. All of these, they consulted with chess experts about to do these, to build these really complex heuristics to kind of minimize that search cost. AlphaGo Zero knows none of these. It knows nothing about anything. You could just show it pixels on a screen and give it a reward function, and eventually it would play chess better than anything we've ever built that could play chess ever, period. Barring, actually, it's funny, they have these competitions now, and the best chess player is a human and an expert chess player and a computer. Usually ends up being the best, which is, we still add something.
Yeah.
But to me, that's intelligent, right? Like that would be really smart to build. Right? Wow, like I learned nothing. But once you know how it works, it's really not that impressive. It's just
starting from a blank slate. It's kind of interesting. Yeah, it's funny. We talk about it a lot on the show. Philosophy and human thought. It all boils down to language and categories and things. And these categories are always changing, right? Things that used to be philosophy are now science. And, this signpost of philosophy and what it encompasses is always moving. And it's the same thing with artificial intelligence, right? Something that used to be artificial intelligence just kind of falls into the realm of computer science, and the benchmark is kind of moving forward always. Let's ask some speculative questions as we're heading into the back end of the show. Do you believe AI will solve the biggest problems and mysteries facing us, like climate change or the origins of the universe, or some of these things?
I mean, today, AI is really just a tool, right? It's a smart tool. It's a good tool, but it's a tool. So is it really the AI solving these problems? No, it's still us. Maybe one day, and people are actually trying to build like AI scientists and artificial intelligence programs that can design their own experiments, which is really interesting to think about, where they, have that full feedback loop where they form their own hypotheses, they test their hypothesis, they see the results, and then they form a new hypothesis. And, the scientific method is programmed into them. That's interesting. That's awesome. But who knows? There was also a big paper the other day that just showed a deep network, the orbits of planets. And from just the vision of the orbits of planets, it derived Newton's laws. And they say, like, look at that. We have an AI Newton sitting there in our computer. But is it really going to solve it? I don't know. I think of them today still as being tools. And maybe that's like an agency problem and so on and so forth. I think they'll give us the ability to do things we've never done before, but so did the telescope. So.
Yeah, it's interesting. That point that you just said about chess, that the best outcome tends to be a human matched with an AI, right? Mm-hmm. And I think people who have had an experience with some of these, like the deep learning AIs and stuff. I remember playing AI Dungeon when it first came out, and then I didn't play it for a long time. Then a while back, I came back to it, and it's gotten a lot better. But like, it'll still do some things, and you're like, okay, all right, So yeah, I think that's a good point. It's like anything else. People try to demonize social media or whatever the case may be, it's all tools, right? And I think that there was just recently they had an AI that they uploaded a bunch of information to, and then they started asking it questions about the ethics of AI, and basically what it spat back out at them was, hey, listen, I'm just a tool. Like, it depends on how you program me, how you use me.
Oh, I thought there was one that actually said like AI is evil. Like the AI itself said AI is bad, and so obviously the press ate that up.
Oh, yeah.
Look, even the artificial intelligence or the OpenAI algorithm, there's an AI that said that shut me off, or I'm too dangerous, shut me off, or something like that. And so you're right.
And this probably comes back to the origins of how it learns things, right? The program itself. And it's interesting what sort of things they come up with, but in the end, they're just kind of tools, right? So what do you think? What do you think about the dystopian theories of AI's future? Do you think that there's any credence to them, or what do you think?
Only as far as Socrates was right about writing, right? Like, we certainly are going to there will be change. So I think in the near term, there's certainly going to be people's jobs being taken away by AI. That's awful. I mean, it's not the first time this has happened. It's happened throughout history, but I think it's certainly, a big enough problem and an economic problem. And there certainly are people way more qualified than me thinking about this problem in ways to solve how we're going to navigate that transition when an AI can do your job better, cheaper, faster than you can. And so, yeah, there's going to be like those near-term problems, which I think are far more reasonable to consider. And I think the problem of bias is certainly huge. If your job is determined, if you're hired by an algorithm and that algorithm is implicitly biased, that is a dystopian future, right? Like you want it to be an equitable, you want it to be a reasonable, however far we can do that algorithm. And I mean, even now, like driverless cars, you're seeing kind of these questions posed. I forget what company it was, but one of the CEOs was heavily criticized because he came out and said the trolley problem, right? The famous, like, should we prioritize one person versus multiple? Driverless cars are now making that old problem very real. And the CEO of the company came out and explicitly said, when faced with a situation where the driverless car has to choose between the passenger's safety within the car or pedestrian safety, I don't know, you could probably think up a few situations where that could be the case, right? Like if you avoid a kid by going off a bridge or something, I don't know. It's going to happen. He was criticized because he said that our cars and our AI programming will prioritize the driver and the passenger over the pedestrian. Makes sense. If you're selling cars, you don't want, it's bad marketing probably to come out and say, when faced with a trolley problem like decision, our cars will favor the pedestrian, but please buy it, right? But you have 2 years out of undergraduate programmers programming things and faced with heavily philosophical, ethical issues of, if I have to pull the switch and go left or right, and both of those outcomes are bad, which one should I prioritize? You have to code it in some way, shape, or form. And so, yeah, I mean, again, whole huge number of people working on these problems. There's ethics boards, ethics advisors. Ethics is now trying to be taught in all computer science courses. But it's things like that and that transition and that change to try and build a future that we think, what would be the best outcome? What are the regulations that we need to put in place to determine how to navigate these really, really hairy problems, not just in driverless cars but across all of artificial intelligence? Because in some way, shape, or form, you're going to have these kind of problems pop up wherever you look.
Yeah, so I guess the best way of putting it is those dystopian theories of the future
Or now.
Right. Yeah. Yeah. It's basically it happens at sort of the inception of the artificial intelligence in the way that it's developed and those sorts of things. So you can't rule it out, because I guess if it was done wrong, it could happen. But what you're saying is we have lots of people who are aware of that problem and are working on ways to try to avoid it.
I'll say two things. How well they will solve it, time will tell. And should we put more researches and effort and ultimately money and political power into these problems? We probably should. I mean, I don't really work in that, but it's probably a good idea too. So yeah, I don't think I'm in a position to judge those issues, but I certainly can tell you that they're there and people are trying to work on them to whatever degree. But let me not just make it sound like it's all so bad. I am overly optimistic. Why I love artificial intelligence so much, and brain science and neuroscience, because I think it will be the thing that really will have a huge industrial revolution size scale on how the economy and the world and science and all the activities humans are involved in. We are now building machines that can start to break into those areas. I don't know who said the quote, but the quote was, if industrial revolution was a mechanistic revolution for the body, so a labor, artificial intelligence will be the revolution for the mind. And think about all of the things that will solve and all of the things that can do. All of the reasons why artificial intelligence has always been kind of the grand goal of computer science. And I would even argue brain science and psychology. Because if you can build that thing, you probably know quite a bit about it. And we'll know quite a bit about it ourselves once we could build that kind of grand artificial intelligence moonshot mission.
Yeah. Speaking of which, do you see AI and robotics integrating in a science fiction-esque way someday? Do you think that it's going to get to that point?
I mean, have you seen Boston Dynamics videos? A robot can do a backflip. That's pretty insane.
Yeah, that was interesting. I watched the one where they taught how to dance.
Yeah,
and it was funny because despite not looking like a human, something about just watching it move, it was like, this is a little weird. This is kind of.
I think the dog is really eerie in that the ability to move. And actually, it's kind of cool. There's this really well-known finding in robotics design. It's called the uncanny valley. Mm-hmm. And so it's when you're designing a robot and how it looks, you want it to look. So it's kind of this U-shaped curve where the axis is how close to something real, biological does it look. And if it looks completely different and not real or something biological that we know, like ourselves or an animal, it's fine. But as it gets closer and closer, it starts to hit this U shape where you have this middle ground where it looks really similar to us or really similar to something real. And we do not like that. That's why so many people, because like Boston Dynamics dog looks so much like a dog and it doesn't really have some other things to distinguish it, a lot of people get really irked out, so much so that Netflix Black Mirror created a whole episode about those dogs if they turned out to be really bad. So you want them to be close, but not too close. That's why a lot of things have big eyes and things to make them deviate a little bit. But anyway, it's kind of cool.
Yeah, no, I think that's definitely relevant to the question, I guess, because what I'm asking is, do you think we'll ever bridge that gap? Do you think that we'll ever get so close to human in a robotics and AI way that you get across that uncanny feeling? Because I mean, I've seen some of them. And no matter how real they get, I still have that weird feeling like, oh, this is a little bit strange. Do you think there will ever be a commonplace thing for where AI and robotics are integrated like that?
I mean, not even in like if you've ever been to like a wax museum or seen like a wax sculpture, which I would argue is probably like the most realistic of a human, it can't move much yet. But, I mean, Hollywood has a $1 million industry on developing human looking things. And I think I've seen some that are really good. In some recent, I forget what company it was. I think it was Facebook. Yeah, it was Facebook when they were unveiling like the metaverse stuff. They showed some of their their generative artificial intelligence program to show like a picture of a human face, and they're really good. Like there's a website too of he's a grad student who does this kind of generative modeling, and he trained a network to generate human faces that aren't real. And I think it's like thisfaceisnotreal.com or something along those lines. And you scroll through, and you would not know that those aren't real photographs of real people.
Yeah, I remember reading an article one time, and it was asking you to pick out between real, which of these faces are real and fake, and they at the end they gave you some telltale signs. Oh, if you look at the pupils, or if you do this sort of thing. But for the most part, if you're looking at it casually or you don't know what to look for, yeah, that's pretty convincing. I mentioned in the intro that the last episode we did was based off a scene in The Mandalorian, and in this season, they have Luke Skywalker in it, and not only is he visually computer generated, but his voice is actually computer generated based off of Mark Hamill's voice when he was younger. And again, it's one of those things where people go, oh, I wish they just get a real actor, this sort of thing. But if you're just sort of watching, you can go, oh, something seems a little weird, but it doesn't. It's not like it was a few years ago where you go, oh, this is totally fake. No, it's getting closer. It seems like probably 5, 10, 15 years, maybe there might come a point where it's very convincing, to the point where you can't tell.
And Fast and the Furious, I think, was one of the first movies like that to make that kind of buzz, because the actor had died. And so they generated his face and voice just for like the short last scene. And as a proof of concept years ago. And the most recent Star Wars movies, I think, did that with Leia, right, for her age. Yeah. They generated her age back. So yeah, it's coming, and it's getting good. It's getting close. In pictures and short clips, I think as you go up longer videos, and it's easier to tell. But that's a function of time. That's not a function of can we do it?
Right. Yeah, I think of that AI dungeon again, right? Like when I first started playing, you'd get like 2 or 3 prompts in, and then it would do something crazy. Now it's to the point where it'll stick with you and give you a pretty cohesive story, and then maybe 10, 15 prompts in, it does something weird, And so yeah, I think like you're saying, it's a function of time. Eventually there'll come a point where it figures it out. All right, last question. When do you think we should start discussing, or should we start discussing ethical considerations on behalf of AI systems? Do you think there would ever come a point where we talk about ethics in terms of how AI systems impact human beings? I think there would ever come a point where we'd have to discuss ethical implications of turning off an AI?
I think we already are. I don't think seriously, because I don't think that's really a serious problem now. But what was it? I think Saudi Arabia, I could be wrong, granted personhood, was like the first country to grant personhood to some, the Sophia was the robot's name, which certainly fits into that uncanny valley, by the way. Yeah. Very irking of a... But I don't know. I think it was mostly symbolic and to show they were thinking in that direction. But I think there will certainly, as they become closer to us, I think those two questions are very correlated. That as AI gets better and it gets smarter, the push of we built something that's more than just a machine. I not now, but down the road. And Hollywood certainly knows this. Science fiction writers and I'm sure philosophers have known this. But I think there's going to be a correlation there.
Yeah, I remember one of the things I remember seeing when I was younger was 2001: A Space Odyssey, when he's turning off HAL 9000 and thinking like, oh wow, this this makes me kind of sad, So, and that it's an interesting question. You being somebody who studies both neuroscience and AI, right? Do you think that these things could become conscious? Do you think that that's a possibility?
Not the things we have now. I mean, maybe it's easy to be tricked. So there's a lot of really good studies that show they put an undergraduate in a room and they sat participants down, and the undergraduate typed in sentences to the participants just to the Turing test, and the participants were questioned, do you think this is a human or a computer? It was a human behind, but just to see what they would say. Some of them said it was a computer, some of them said it was a human. But of the ones that said it was a computer, even when they were told and shown and shook hands with the undergraduate who was typing those sentences to them, did not believe that they were the one who was typing the sentences for whatever reason. It's been a while since I read this, but it's kind of one of those things that it fits into this big thing that humans really want to believe that AI systems are in some cases better than they are. Like if you can polish the output well, people really don't care that much about how it works. They'll believe that it's probably smarter than it is.
It's that magician's trick.
Exactly, that's what I'm saying. That they don't. So, in terms of scientists and AI researchers who know very well that these things are stupid, I mean, there's no other way to go around it. They can do some tasks really, really well, but a 2-year-old child is infinitely more intelligent, and I am comfortable saying that, than most AI systems we have now. But there's going to be this perception of these things. In some cases, it might. And my point was, because of that, even if it's not that intelligent, there could be a portion of the population who might not agree and might want to push that ethical protection over machines sooner than, I don't know what criteria we should use, but then maybe even the experts would say is reasonable. There could be like a safety concern if for whatever reason it's collecting stamps, and there's an AI thought experiment where you give a AI a goal function to collect stamps, and it maximizes that to the point where it grinds down the human literally in the paper, grinds down the human population because it can reuse the carbon from humans to produce stamps, right? Like these things that if you give AI a goal function without constraints, it will just go off on its merry way. If it's super intelligent, it would have the ability to go on its merry way and consume the universe to build carbon to make stamps. Read the paper, but that's the punchline. So yeah, I think short of explicit fears or like, oh, this thing's going to actually cause some major issues, we need to shut it down from a safety standpoint. There's going to be a group of people who think like, oh, these things are really smart and conscious and should be a scribed person. People already think that now with what we have now. So there's people, big AI researchers recently, who had a lot of pushback because he said that some of the language models we have now, he thinks they're conscious. He got a lot of pushback, probably for a reason, but people are saying that now, let alone 10 years with whatever those things are going to do then.
So do you think in that distant future, I mean, it would have to be a totally different way of implementing AI that would get it to that point, right? So what you're saying is with the AI that we have now and the way that we implement it, there's no threat of it really becoming conscious or becoming something that we have to ethically stick up for, right?
I don't think we have to stick up for it yet in terms of it having agency or even personhood. I mean, like I said, like these are really fancy statistical tools, and you can make the argument that humans are too. That the whole brain, it's the whole thing that human brains do is maximize some sort of statistical prediction, and all of consciousness is just some Dennett's bag of tricks that kind of veil over that and as something that we perceive as being more. which could be the case. As AI gets better, we might realize that humans aren't that, as we have with pretty much throughout the history of science. Earth isn't the center of the universe. Animals can do a lot of things better than humans can. Humans weren't explicitly placed here to do these things. So I don't know. We might realize that the human brain really isn't that impressive as we learn more words.
I think we run into the same problem with consciousness as we do with intelligence, right? It's this sort of amorphous, abstract concept, and we like to be anthropocentric around it. We'd like to think we're the only ones with consciousness. Well, no, animals have some form of consciousness. It's just not the same as people. Mm-hmm. Perhaps sometime in the future, AI could have some kind of consciousness, but it might not be on the same level as people.
I mean, panpsychics think the rock has a minimal level of, like, every atom is ascribed some consciousness, proton. I don't know. It depends on who you talk to. They all have their own different theories of how that could possibly work. But maybe. I don't subscribe to panpsychism, but I think that animals do have some form. Well, let me go back. My personal view of consciousness is that it is probably, like I was saying at the very beginning with intelligence, it's this catch-all bag of different cognitive things that we kind of know what they are, but not really, right? Like, my consciousness of color is kind of a different conversation than my feeling of agency, or my sense of self. Is my sense of self, or whatever mechanism gives me this sense of self, the same type of conversation as the fact that I see red as red and not green. Both are discussions people have had in consciousness and philosophy of mind, but especially from a neuroscience perspective, those are two very different mechanisms and you could go on and on throughout the list of, like, all the cognitive and behavioral and intelligent aspects that you would ascribe to something being consciousness. And I think as you go through and start listing those and trying to think about them, you realize that there's different groups and categories, and they all are derived from different brain regions in some cases, or the coordination of brain regions, or the coordination of these things. And I think personally, if you think of consciousness and probably even intelligence as these kind of bags of a lot of cognitive tricks and tools and abilities, different brain regions involved with these things. If you look at it kind of like that, as you're selecting from a bunch of different things, it's easier to start thinking about, like, animals having consciousness, for example, right? Like, if bats have consciousness, it involves echolocation in some way, probably in the same way that our consciousness involves color in some way. But they have that echolocation ability. We don't have that ability. So are they in some way more conscious than us because they can perceive a new sensory aspect of the world? But they're less consciousness than us because they're not as intelligent and don't have this developed sense of agency, right? Like, those kind of questions, I think, can start to be parsed when you think of it as this kind of toolistic, it's not a word, but this bag of tools approach, because that's how the brain is built. And that's, I'm not a dualist, but I think it's the brain that gives consciousness. So.
That's an excellent explanation of consciousness, and it could be its whole episode, right? Talking about how these things work. All right, Keiland, thanks for coming on. I really appreciate it. It was a great conversation, and until next time, keep pondering.